We're going to move from simplifying singular rational expressions to multiplying and dividing rational expressions and then simplifying the final solution. You'll notice that in this example, it's somewhat similar to some things we've done before. We have two fractions being multiplied together, and it's already in factored form. We have common bases and exponents that we're multiplying and dividing, so we have to use those appropriate rules. First thing I notice is I have a 7 and a 49, and 7 over 49 reduced to 1 time and 7 times, so I'm going to put a 7 down in the denominator of the second term. I notice I have an x squared and an x to the first. Common bases, therefore I subtract two exponents and keep the answer where the greatest exponent is. So I have an x in the numerator. Next I have a y and a y to the fourth. I'm going to once again subtract the two exponents, so it's a 1 and a 4, get a y cubed, and that's going to be in the denominator because the biggest power is in the denominator. Notice I have a z cubed and a z. Biggest term is in the denominator, subtract the exponents, so that's z squared. And that takes care of those. And then the only thing I have left is the 12 and the 14. And those reduce. 2 goes into both, 6 times here, 7 times here. And now I can take a look at this and reduce anything that's left. I see the two 7s reduce out. And left with x over 6y cubed z squared. And that's my simplified product. Now we move into more complicated terms where it's going to take factoring in order to reduce. Remember, once again, we can only reduce multiples or divisions of factors that are exactly alike. We may never reduce across an addition or a subtraction. So in this first term, you'll notice the numerator is already in factored form. The denominator has a GCF of 4, leaving you with b minus 3. That's multiplied by, I'll factor the numerator. Need to find out what multiplies to 3 and adds to negative 4. That's a b and a b, and a negative 3 and a negative 1. In the denominator, I have b and a b. What multiplies to negative 30 and adds to 7. That's a 3 and a 10. Negative and positive. And now I can reduce anything on the numerator that's the same as in the denominator. So you'll see I have a b plus 3 that reduces, b minus 3 that reduces, and then that's all I have that's in common. So my final solution is b minus 1 over the quantity of 4 times b minus 10. And I can leave all those solutions in factored form. Here's another example using some of the factoring techniques that we've already talked about. In the numerator, I need to find two things that multiply to 9 and add to 6, and that's a plus 3 and a plus 3. Denominator, what two things multiply to 25 and add to negative 10? That's an a minus 5 and an a minus 5. Next term, what two things multiply to negative 20, add to negative 1? That's a 5 and a 4. 5 being negative, 4 being positive. And then finally, what two things multiply to 12, add to 7? That's going to be a 4 and a 3, both being positive in that case. Look for the terms that exactly match, both in the numerator and the denominator. The a plus 4's reduce, a minus 5's reduce, one of the a plus 3's reduce, leaving me only with a plus 3 over a minus 5.
This problem is very similar to the others that we've had, except for the fact that this term on the lower right is written backwards, and these two are a little more difficult to factor just because of the leading coefficient. So let's get to it. I'm going to take it one step at a time, factor each one going across, and then I'll do the simplified form down below. So in order to get a 2, I need a 2 and a 1. So I'll go 2a and a. To get a 9, I'm going to either need a 3 and a 3. So if I put a 3 here, this gets me a 6 in this multiplication. Add another 3 to it right here, and I should be good to go. So I'll put a 3 here and a 3 here. Addition in both cases. So this is the first term. We'll go across this way, if you will. That will be what? An A. I need what multiplies to 49, adds to 14. That's a 7 and a 7. In the denominator, let's see. I can use a 3a and an a because that's the only way to get 3. And then I need a 14, so probably a 7 and a 2 because I'm going to need a 19. So 7 here, which is 21. 2 here, which is 2, and 21 minus 2 is 19. The 7 needs to be positive, the 2 is negative. And then lastly, I'll rewrite this over here, so that's a squared minus 6a plus 9. Pretty easy factoring job on that problem. And that's a minus 3 and a minus 3, because negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. Now I'm just looking for my cross reductions, things that are exactly the same. I notice here's an a plus 7 and here's an a plus 7. I have a, it's looking like that's it. I think that is it. So we've got 2a plus 3, a plus 3, a plus 7 over 3a minus 2, and I'm going to write a minus 3. Since there's 2 of them, I'll go quantity squared.
All right, so we've got a little word problem here. Velocity of a spacecraft must have to escape the gravitational pull of the Earth is called the escape velocity. And the escape velocity for a spacecraft leaving the Earth is about 40,320 kilometers for 1 hour. And we want to write this in terms of meters per second. So what I'm going to need to do is do some dimensional analysis. This is a little review. So in this case, I need to know how many meters are in a kilometer. Well, there's 1,000 meters in 1 kilometer. And then I need to know how many seconds are in an hour. And then I have 1 hour, 60 minutes. And then in 1 minute, there's 60 seconds. So you'll notice now I get to reduce kilometers with kilometers, hours with hours, minutes with minutes, and I end up with units of meters per second. I'm going to multiply the numerator and divide that by the denominator and end up with my meters per second unit. And I end up with the following, roughly 11,200 meters per second. That's my escape velocity. Now we're going to divide these terms. Dividing rational expressions is the same as dividing fractions. I want to multiply by the reciprocal. So in this case, I have 8 over 20x cubed multiplied by 25x squared over 44. I'm going to take and reduce where I can. So the 8 and the 44, there's a 4 that goes into both. 2 times here, 11 times here. 20 and the 25, 5 goes into 4 times and 5 times. And then we've got this x cubed and x squared. Got a 2 and then a 5. The x and the x squared, bigger terms in the denominator, subtract the powers, that's an x, and I have a 4 and an 11 left. So I'm going to multiply what's left. It leaves me with 10 over 44x. 10 and 44 reduce because 2 goes into both. 5 times in the numerator, 22 times in the denominator, and the x is left over. So that's my reduced solution. Factoring is going to come back into play. We'll take and rewrite while we factor. So this denominator here goes to x minus 6, x minus 3, going to multiply by the reciprocal, so I put an x minus 6 in the numerator. Denominator factors into x plus 5, x minus 5 because that's a difference of squares. Now I can multiply, reduce any term that's exact, or any factor that's exactly like in the numerator and denominator. So I go ahead and do that. You'll notice everything in the numerator is reduced. That doesn't make the numerator equal to 0. Anything over itself reduces to 1, so I have a 1 in the numerator over x minus 3 times x plus 5. And there we have it. Here we go again, very similar example. We have some greatest common factors in this case. The numerator has a 6, leaving me with a plus 1 over a minus 1. Going to multiply by the reciprocal, I have a 2 as my GCF, a minus 1. Denominator factors into a plus 2 and a plus 1. I reduce like factors once again. The a plus 1's reduce, a minus 1's reduce. In the numerator, I'm left with a 2 times 6, which is 12, and in the denominator, I'm left with an a plus 2.
So again, in this division problem, there's a couple of things I'm going to look to do. First of all, I'm going to multiply by the reciprocal, and then in this case, I'm going to rewrite it with my squared term first. So let's go ahead and do that. I have 2a squared minus a minus 15 over a squared minus 2a minus 3 multiplied by negative a squared plus 1 over 2a squared plus 3a minus 5. And then I'm going to do just the quick little GCF here of a negative 1 to factor that out. I'll rewrite the whole thing again. So let's come over here. I have 2a minus a minus 15 over a squared minus 2a minus 3 times, factor out a negative 1 and have a squared minus 1, and then 2a squared plus 3a minus 5. And then factoring from here should go relatively quick, other than the fact that I have these 2's out in front, so I have to do a little bit of guesswork. I need a 2 and a 1 to get 2. I need 15. 15 is 3 and 5, or 1 and 15. I'm going to go with 3 and 5 because I need a 1 here. I'll put my 3 here, which gets me a 6. And a 1 is not going to do it. Oops. And that wasn't a good idea anyways, so I'll put my 3 here and a 5 here because 3 and 1 wouldn't give me a 15. So now I have 6 and 5, which gets me 1. I need a negative 6 and a positive 5. So there's my factoring in that case. In the bottom, two things that multiply to -3 and add to -2. That's a 3 and a 1. 3 being negative, the 1 being positive. Notice I have my negative. Perfect squares, a plus 1, a minus 1, over, again, I'll use a 2a and an a. I need a 5, so that's 5 and 1. If I put a 5 here, that's going to give me 10, probably too much, so I'll put my 5 here, my 1 here. So notice there's a 5 and a 2, which is 3. And I need that 3 to be a positive, so my 5 is positive, giving me a positive 5a. 1 is negative, negative 2a, and I'm good to go there. Now I look to reduce anything exactly alike on top of each other in any way, shape, or form. So the a minus 3's go, the 2a plus 5 goes, the a plus 1 goes, oh look at this, and the a minus 1 goes, and I'm left with this negative sitting right here, so I end up with a -1 as an answer.